Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome to WebRTC Live. I'm your host, Aaron San, founder and CEO at WebRTC.Ventures. We're a custom design and development agency focused on building live video applications. We're here to help you take your application live. Thank you for joining us live today on YouTube, LinkedIn, and Twitch. And welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. Joining me today is computer science professor Ali C. Begen, who is founder of Networked Media, a consultancy based on IP video technologies. Ali's a former tech lead at Cisco and recognized expert in media streaming, holding over 40 patents and even a technology and engineering Emmy Award. He's also deeply involved in the development of media over QUIC, or MOQ, spelled MOQ, and that's what we'll be discussing today. Thanks for joining me today, Ali.
Sure, thanks for having me. Nice to be here.
It's a pleasure to have you here. And this is a really interesting topic that I know a lot of people are going to be interested about, potentially the future of WebRTC, maybe a replacement to WebRTC. So let's start with what is media over QUIC, what is MOQ, and what problem is it trying to solve?
Sure. So Media over QUIC is an effort that we started a bit over more than 2 years now in the IETF, Internet Engineering Task Force, which is the organization, public, open organization that builds all these, different types of internet protocols. I mean, it could be TCP, UDP, QUIC, all the WebRTC protocols and things like that. And QUIC has been standardized a while ago. And people have been contemplating about, using QUIC for, real-time media, not just for streaming media, which we are already using, for HTTP streaming. And, this was a collective, there was a collective interest. And, eventually there was a BOF, and then that led to a working group. And that working group has been meeting almost 6 times a year. 3 times during the IETF meetings and 3 times outside the IETF meetings. As a matter of fact, we just met in Stockholm a couple of weeks ago, and about 15 to 20 people. So we tried to design all the protocols, details, stack, and everything. And then hopefully, we already have some implementations out there, and hopefully it will be an RFC. Probably not this year, but hopefully next year. But we will start seeing some deployments relatively soon.
Yeah, so this is similar to the process that WebRTC went through, where going through standards committee takes a lot of time, takes a lot of hard work from people like yourself. It is not
just one person's or one company's protocol, right? I mean, this is supposed to be a collective effort. And, you might want to do something in a certain way. Somebody else wants to do it in a different way. So we are trying to understand what are the pros and cons and trying to understand the trade-offs so that, we are trying to do our best to please everybody and address all the use cases. And as I met, we are talking about use cases. The primary use case for media over QUIC was actually a relatively smaller portion of the entire media delivery spectrum. But I will show you a couple of slides where we, over time, came to conclusion that if we are going to go through all this hassle, why don't we actually design a single protocol that might replace all the streaming protocols we have and all the real-time protocols we have today, and maybe a common single protocol will make life easier.
One protocol to rule them all.
Exactly.
Well, and that's definitely something.
Yeah.
I'm sorry, go ahead.
I have a couple of slides, Aaron. I mean, anytime I can share them.
Yeah, absolutely. Yeah, I think that's definitely going to be something interesting to our viewers, is to understand the use cases where MOQ is particularly useful, and then how we balance that with existing protocols like WebRTC. So yeah, let's get into it.
Yeah, I've been a streaming guy myself pretty much my entire life, like starting with my graduate studies and then my tenure at Cisco. But I always had the pleasure working with real-time media people. Like in Cisco, we had our own conferencing solution. Later on, WebEx joined and telepresence and so on. And I know how frustrated they can get over time. I mean, this slide is not really meant to upset anybody, but it's hopefully, I mean, we are working towards making everybody's life easier. WebRTC has come a long way, and we just want to make it better. So please, I know that this is a WebRTC community, so don't shoot me down right away, but I'm more than happy to answer any questions. So QUIC is a really interesting transport protocol. Originally designed by Google, later on, they brought it to the ATF, and then it took a while before it became an RFC. But today we have lots of different independent implementations, and pretty much all the browsers we have, the modern browsers we have, they already support HTTP3, which is based on QUIC. So QUIC is meant to replace TCP. And it can effectively do that. It is a UDP-based protocol, but it has all the nice features from TCP as well. And on top of that, it has other features. So first of all, QUIC might be a single connection, like a TCP connection, but it is not really a single lane path. It is a multi-lane highway type of thing. There are multiple streams within a QUIC connection. And we can carry different types of media or different types of data. It is really up to us with their respective priorities. And because of these multi-lane kind of architecture, multi-stream architecture, we don't really have the problem of head-of-line blocking that we usually have in TCP. So it's a single QUIC connection with 3 streams here. On the sender side, we have a user space or a customizable, which is running in your application. There's a congestion control algorithm and retransmission machinery. So you can customize your algorithm for that. And in this case, I have 3 streams. It's just an example. I put my audio data and maybe chat messages on the highest priority lane, and then desktop sharing on the medium priority lane, and then video or images or any other background data file on the low priority lane. And then these things are transferred to the client in a reliable manner. And if something is going to be too late, you can always drop it out and just skip it. It's not a problem. There is also UDP, datagram mode of QUIC, so there is no reliability in that case, and it will behave just like UDP. So we have in-order delivery guarantee within a stream, but obviously because of the different priorities, we don't really have any delivery guarantee among the streams. And then this is a single QUIC connection. Everything is encrypted. This is really important. So with TCP, obviously, everything is in open, so you need a TLS connection for that. With QUIC, encryption is built in. And so the ISPs or the states, governments, or anybody else who owns the network, they can't really see your traffic. They can't really see what you're carrying. This is a bit detailed slide, but I really want everybody to understand this. QUIC really gives us the flexible loss recovery options. So let's say these are my bunch of frames, packets belonging to different frames, and there are iframes every so often, and then there are a bunch of other frames that depend on this iframe, for example. And if you lose one of the packets, let's say packet number 4 or frame number 4 here, right? Some packets belonging number 4. What TCP needs to do is that it needs to recover number 4. And then it will, in theory, take forever it might take forever, in theory, to recover that. And that's really the head-of-line blocking. Even if you receive frame number 5 or 6, doesn't matter. TCP has to recover that number 4. But QUIC has a lot of options. First of all, it can do what TCP does. It can skip, maybe the frames that depend on this frame number 4, and then continue with the next iframe and so on. And then, or it might just, continue with the next scope and then try the skipped frames later. or it can try recovering missing data by using some sort of forward error correction. So all these are possibilities within QUIC, as opposed to having a single option in TCP. So this is an illustration to demonstrate how QUIC may outperform TCP. Here I am just showing an illustration, but in an IBC paper a couple of years ago that I am citing here in 2023, we showed this diagram in practice. So on my x-axis, I have my latency budget, and on the y-axis is on-time delivery. So I would like to deliver every of my packet, 100% on-time delivery rate within the latency budget. And then with TCP, the curve is going to look something like this. 10 seconds is a long time for networking. So if you give 10 seconds for TCP, unless your connection goes away for 10 seconds, eventually you're going to hit the 100% on-time delivery success rate. With QUIC, our expectation is that at lower latencies, our success rate is going to be higher. So over time, over long terms, like 1 second, 5 seconds, 10 seconds, the difference between TCP and QUIC doesn't really matter much. But at low latency values, I think we are going to get a lot of benefit from using QUIC. So we have done a lot of research in this domain. My students, and the other colleagues that I worked with over the past several years, and then there are other many fine researchers working in this domain. The common conclusion that we have come up with so far is for timely delivery. So if there is some sort of latency concept in our delivery, QUIC is going to perform better than TCP, especially in congested and lossy environments where there's packet loss. But you need to have certain application layer features to make the best use of QUIC. Otherwise, this is not going to work really well. So if you today just take a media source extension capable JavaScript client that will stream -HLS, for example, that is usually historically fine-tuned for HTTP 1.1 or HTTP 2, which runs over TCP, is not going to really perform much better or any different when you run it over HTTP 3, which is running over QUIC. So it's not going to really give you much benefits. You need to have certain application layer features to make use of that. And then there are again some citations over here if you would like to learn more. This is one diagram that I pretty much show in all of my presentations. This is a latency spectrum. We have different type of applications, and we used to have all these, high latency streaming media, 40, 45 seconds or 60 seconds latency, and that's still unfortunately quite common for big events like Super Bowl. But then when we focus on low latency, where there's a lot of live sports stuff is happening, social media, Twitch type of applications. And then this is also where most broadcast TV happens, like cable, IPTV, satellite. And we can achieve these low latencies or get close to those latencies by using low latency extensions for Dash or HLS. But, it is usually quite fragile. Sometimes it doesn't work. Sometimes something is blocked, so the latency still gets over to 20, 30 seconds or so. And then on the other extreme point, obviously, we have near real-time latency applications, like if I want to control a drone, if I have a surgical robot, metaverse applications, voice over IP, video over IP, cloud gaming, and all that. So for everything on the left-hand side, we used to have, and we still heavily use them, Dash HLS. For low latency, we have low latency Dash and low latency HLS extensions. And then for everything else, we used to have WebRTC. And WebRTC has been the de facto protocol for any application that needed a latency of less than a second. And then the initial motivation for Media over QUIC was somewhere in between low latency Dash, HLS, and WebRTC. So there was this little spectrum over there where we couldn't really get the latency down from Dash HLS side, but we couldn't really have the unreliability of WebRTC either. So Media over QUIC transport was initially designed for this. But then we all know about the complications and difficulties that WebRTC developers have faced in the last 10, 15, 20 years, right? There's complicated peer-to-peer session establishment. It is not really latency tunable. It's always the minimal latency. It doesn't really care much about the quality itself. There is no caching, unfortunately. There is no CDN built-in for WebRTC stuff, and that really limits the scalability. Limited set of codecs, not really big support for newer codecs, multi-channel audio, that sort of thing. And DRM is always a big issue for WebRTC. So over time, we, as I mentioned at the beginning of the presentation, we started to think, like, if we are going to do all this work, and if Media over QUIC is so capable, why don't we replace the entire spectrum with this? So yes, we have Dash HLS for streaming, we have WebRTC for near real-time video, but if Media over QUIC is meant to be latency tunable and configurable, and it is cacheable, and it works over the latest, greatest protocols, it is encrypted, secure, and all that. So why don't we just use this, right? So the idea, Arin, is why can't we just unify real-time communications with content delivery? This is going to bring us a lot of advantages in practice. It's going to lower the cost for CDN, service providers, content providers. And then with a single client framework, I can actually support all types of applications. So not just for VOD that I use Dash HLS for, or live streaming Dash HLS for again, or WebRTC for cloud gaming, drone control, and so on. I can have this Media over QUIC transport protocol with the fetch capabilities, fetch API that will support Dash-like features, and subscribe model that will support WebRTC type of features. So this is the last slide I want to show before we get maybe into more detailed discussion with questions. So Media over QUIC transport, if I need to define it in a single sentence, it is a latency tunable protocol, cache-friendly protocol. It's a pub-sub media delivery for both ingest and distribution, not just for distribution, but also for ingest. So I have my sources, media sources, like a camera and microphone here, and I am the publisher. And as you can see, there are a bunch of relays in the middle, and it could be just a direct connection to the subscriber as well. And subscriber is getting all these media info, data from me over different media tracks. And then there's a bidirectional control stream, a quick stream that is highly prioritized to, carry the backend for the messages between the publisher and subscriber. The connections between the publisher and the relays, and the subscribers, or between the relays, it will be a web transport connection, which is a feature developed again by the IETF and W3C. It is a secure multiplexed bidirectional real-time transport developed for HTTP3, or raw QUIC. So if you are in a non-browser environment, we got you covered, so you can do everything over a raw QUIC connection as well. And then the nice thing about this Media over QUIC transport is that it is not just sender-side congestion control or receiver side or client side, bitrate control or bitrate selection. Any of these entities, from publisher to the relay, from relay to the subscriber, can actually perform some sort of rate adaptation and can perform their own congestion responses. So this is really an active area of development that we are working on, and this is something that really separates us from the Dash HLS as well as WebRTC. So, Arin, I would like to stop here and see whether you have any questions, or if any questions from the audience, and then we can continue.
Yeah, absolutely. So this is really interesting and very thought-provoking already. So thank you, Ali. A couple of things, like you mentioned, web transport in that last slide of being how you would communicate between how you send between the relays, which is interesting. So this kind of gets into the whole concept of what was WebRTC designed for and what are the ways that we're trying to use it today, right? Because in the slide that you had a couple of slides back where you showed that, that spectrum from high latency to near real-time latency, and great listing there of all the different use cases and the type of latencies that it's acceptable in them. The one that WebRTC was designed for was really just the one around video conferencing, essentially, right? The near real-time latency, the what we're doing, what you and I are doing right now in talking to each other, right? Or what you would do in a standard meeting tool. That's what WebRTC is built for. But when we have looked at using it in other cases like drones to streaming media and that whole sort of range, WebRTC contains a lot of things that maybe aren't necessary for those use cases, right? Correct. So you're kind of unbundling, it's the concept of unbundling, right?
It comes with a lot of baggage, that's for sure. And then at the same time, it doesn't need certain things that we need for newer codecs, newer features, and newer distribution paradigms. So, I mean, if it is just two of us talking right now, and obviously people are watching us on YouTube or Twitch, which is the streaming part, it's not the WebRTC part. But I mean, imagine that this conference that we have right now was over 100 people.
Right.
It will be quite complicated. Who's going to receive whose video, who's going to multiplex, or is there going to be some sort of SFU or MCU somewhere in the middle? That's going to do a lot of encoding, transcoding, or changing the codec, vice versa, sort of. So MediaWork really wants to get rid of all those problems. I mean, if you want to use VVC or AV1 or HEVC, whatever, I mean, as long as the two peers are negotiating with each other and they are okay with that, that's fine. It's not like, oh, this is not really supported by MediaWork Quick Transport, right? I remember the old days in the ATF, like where H264 versus VP8 was a big discussion. Which one was supposed to be the mandatory to implement codec? And then people couldn't decide, so they ended up accepting both. But then if you have two options and then people still allowed to implement only one, then it's not really very interoperable, right? So that's so we want to really get rid of those problems and focus on the media delivery aspects, and we can let anybody use these APIs for their use cases.
Perfect. We've got a question from a viewer here, Jorge Barantes. Would like to know, what are the requirements in terms of current available infrastructure? What's needed for mass consumption?
All right.
When delivering over MOQ, I assume. Yeah. So big question here, really.
This is an important question. So first of all, if we are going to use, let me put it this way. Most users, I think, will end up consuming MediaWork Quick in a browser. And, with browser, if you're, whatever browser you are using is going to support web transport at the moment. And I am using Chrome heavily, and Chrome supports web transport. Firefox also has support for web transport, but Safari WebKit is, support is coming hopefully this year. So that will be the main environment, medium to consume MediaWork Quick media. So there will be clients, maybe based on JavaScript, TypeScript, or other types of clients, or there will be some native applications that will also consume MediaWork Quick data. For if you are on the publisher side, obviously you need a publisher component, and we are developing an open source publisher ourselves. There are a couple of other open source implementations out there, so that will be something that needs to be developed. But I think that the main thing that I would like to show over here, let me switch to slide mode again.
Sure.
So the main thing, I think the main win for MediaWork Quick is going to be the relay support. So, on the top, we have all these, different types of applications, as you can see: webcams, classroom teaching, presentations, drones, security cameras, live sports chat, and anything like that. So they are so-called publishers, but they could also be the subscribers. If it is a two-way video conferencing or cloud gaming, it could be the subscriber as well, right? But the main development and infrastructure requirement, it's not really infrastructure, it's mostly software. So it's going to be really CDN, MOQ CDN. It will be set of relay nodes. Today we have lots of CDN providers out there in the public, and they have all these thousands of HTTP servers all over the place, right? So for them to be able to support MOQ at the same scale, they will need thousands of MOQ nodes as well. So, relay points where this fan out, this replication points will be deployed. And then, all these relays will support sending the data, distributing the data, or ingesting the data from the subscribers or the publishers respectively. So I think the main challenge is going to be, if we really want to see MOQ in a large scale deployment, we need to have certain CDN support, MOQ CDN support that is public, that is it is open to rent and so on, so that we can also use their services.
And so what you're referring to there is kind of having commercial providers providing that, kind of cloud providers.
Correct.
Because right now it's not the model that typical CDN providers use. It's not based on
No.
MOQ, but they're certainly investing in it and looking towards that in the future, I assume.
Right. So, but let's put it this way. So Zoom or WebEx or any type of WebRTC application today, right? They have all these data center servers in different places, in the world. They have, data centers in Europe. They have data centers in North America, Asia, and so on. So as opposed to deploying all these SFUs, MCUs, or other Zoom servers, let me put it this way, I can't really call them WebRTC servers because, Zoom is not exactly WebRTC, but ignoring that for a moment, all these companies are already deploying lots of servers everywhere to be able to support all the video conferencing requirements, right, from all their customers. So as opposed to doing that, Zoom or Cisco WebEx doing that, if there are public CDNs that will offer MOQ CDNs, they can just offer this service and then use somebody else's CDN to help with the distribution. So they no longer need to maintain a Zoom data center, a WebEx data center, or Google Meet data center, and so on. So that's the idea. I can use that for conferencing purposes, and then if it is Super Bowl time, I'm going to use it for streaming purposes, right?
Right.
That's the idea we have.
That makes sense. Well, thank you, Jorge, for your questions. So kind of, to summarize on the client side, right now we've got Chrome and Firefox support, but Safari, will come along at some point for sure, as they do.
I'm sure it will.
And
it has to.
And on the ingest side, not you could use like a WIP or something like that, but the ingest side is relatively small in terms of mass consumption. Presuming kind of a use case like this, there's just a couple of us doing ingest, and then how do you get it out to the people? Hopefully, it's going to be based on a MOQ implementation of a CDN style model in the future, or I suppose you could build your own infrastructure, basically an array of the MOQ relays that you describe in there, that sort of fan out your own.
For a company, for the internal distribution, for a company's wide meeting, for example, right? Let's say you have a bunch of people, engineers in North America, and a bunch of other people in India or Japan or whatever. So, if you have all these MOQ relays internally, you don't really need to carry all this traffic back and forth all the time. Relays can internally, in the intranet, they can distribute the content for you. And at really very low latencies that WebRTC can achieve. Yeah, that's the idea.
All right. Well, thanks again, Jorge. And we have another question here. Upon asks, how does QUIC establish a connection between peers? So thinking with respect, comparison to WebRTC. And this is one of those things that's challenging about WebRTC, right?
Yeah. So first of all, QUIC to the network, it is just a UDP connection. So if you are not able to send or receive UDP packets, obviously this is not going to really work. So it happened to me a few times where I wanted to demonstrate our MOQ demo, and then in the convention center, unfortunately, the UDP traffic was blocked, so nothing really worked. So that's a problem. But hopefully things will improve over time. We are seeing now a lot of HTTP3, like quick traffic being transmitted from YouTube servers. Unless your ISP or your enterprise network, specifically blocks that, I mean, things usually work fine. Obviously, I don't have it in my slides, but if you want to watch something or if you want to join a conference, we have a special track, a special JSON formatted information called catalog, and that allows you to, gives you the identifiers like the locations of the endpoints that you are supposed to connect to receive that stream or media conference, video track, whatever. So there is some sort of manifest or playlist file that is called catalog in MediaWork terminology. So somebody needs to give you this file, or you need to know where to find this file. And then once you know where to connect to, and once you connect to, there is namespaces, track names, and so on. And then from there, you will be able to, I would like to subscribe to this particular conference with this track name. I just want to receive the audio, not the video, or I want the 4K video versus stereo audio. So you can do any of these combinations. So there are ways to do this, but then how this will be really user friendly or really as easy as that people go to YouTube and so on. It will take a while, but we will get there. So. Yeah.
All right. And another question. Thank you, Apan, for your question. Question from Ali. As you said, we can implement application layer loss recovery. How can we ensure compatibility and interoperability between loss recovery implementations used by publishers, relays, and subscribers?
That's a great question. Right. So this is a great question. So if let me go back to that slide. So if you are using QUIC stream mode, it will be retransmission based. So and whatever you would like to do, any fancy thing that I have listed over here, like unless you modify the logic, QUIC is going to behave like just like TCP. It will try to retransmit. If it is lost again, it will try retransmitting again, right? But the advantage of QUIC here is that maybe now you know that packet or that frame, whatever, the packets that belonging that frame will be too late by the time they're delivered, or they are already past their deadline. So you can do a stream cancel, which is available in QUIC API, and that allows the QUIC skip all that data, and then you can continue with an if stream, for example. That's that's the sender side operation, and this doesn't really require any interoperability with the client side. The client is going to expect packet 1, 2, 3, and then 4, 5, 6. But if it sees like the next packet is going to be 30, for example, it knows that those packets are skipped, and then it will play accordingly. If you are going to do some application layer for the correction, obviously this is something you need to know in advance. Both the FEC encoder, which is on the sender side, and then FEC decoder, which is on the receiver side, they need to understand what each party is doing, right? I need to be able to understand what the FEC encoder is doing so that I can actually use them for FEC decoding in case there's packet loss. So in that case, you need to have some sort of interoperability, but that's application layer stuff. That's not really QUIC layer stuff. So for QUIC, retransmission is the way to go, and it is built in. And if you want to have these latency-aware operations that I am showing over here, you need to have all this stream cancellation logic, and that needs to be on the sender side. Again, that doesn't require any client interoperability. And for the other part of the question, publisher relay, to publisher relay 1 is the receiver. To relay 2, relay 1 is the sender, relay 2 is the receiver. So, these are all separate QUIC sessions between each other, and they will behave accordingly. So it's not like just one client server. I mean, there are multiple QUIC connections going over here.
Perfect. Thank you. Excuse me. Thank you, Ali Shabani, for that question. And Ali also has another follow-up question for you. As you know, we have 5G new calling, which uses data channels. Do you think we will see QUIC and MOQ used in the telecom domain in the near future?
Well, I hope so. Definitely. I mean, I'm not really too much into the, link layer, physical layer stuff, but, I know that these guys are trying their best to minimize the latency for transmission at the physical layer. And we don't want to really waste those efforts at the transport layer or application layer. So, the minimal latency you gave us, we will do our best so that, hopefully I can call my friends in a different continent much faster. I can have a much more interactive conversation and so on. So yeah, I guess we will, even if it is not called MOQ, it will be MOQ-like concepts, I would assume. So I think those will be adopted by the telecom companies as well.
Excellent. Thank you, Ali, for those questions. So yeah, Ali, can you talk us through a little bit the protocol stack and a typical MOQ development?
Yes. So let me switch the presentation mode again. So the protocol stack is, starts with the UDP, which is, QUIC is based on UDP. It's just transmission of bits. And web transport and QUIC, which is the layer responsible for, again, packet loss recovery through retransmissions. There's congestion control, but it is in the user space, so you can customize the congestion control for yourself. So it could be media specific or media aware congestion control, and the stream management, like all these different lanes on the highway, I will say, right? And then in the working group, in the MOQ working group, what we are working on this MOQ transport. We are in version 11, I think, right now. It is an adopted working group document. Obviously, there are still a lot of open issues on GitHub and things like that, but we are getting there. So all the stuff we are working in the working group belongs to this media or QUIC transport layer. And then we have the application layer stuff, application layer bindings, and there are some drafts already adopted for this as well. And this will be one for more like conferencing applications, which is a low overhead container format, which is using a web codecs. And then there is a CMF-like packaging format for streaming type of applications. So that stuff will be used by the applications, MOQ applications using MOQ as a transport. And for the relays and at the transport layer, we will be using MOQ transport. So that's why I have this separation over here, application versus CDN. So anything except the red layer will be implemented by the CDN. The CDN needs to support QUIC, web transport, and MOQ transport, but they don't really need to understand the streaming formats because to the relays, the stuff is encrypted. We only expose certain metadata in the headers or extensions so that the relays can do some interesting stuff, but they are not meant to change the encoding, or they are not meant to change the bits or transcode it into something else and so on. So anything below the red layer will be implemented by the CDN, and the application developers will need to implement the red layer.
So let's talk a little bit more about that application layer. One of our viewers' comments, talked about doing application layer loss recovery. You've mentioned before the importance of if, for instance, if you had a WebRTC application now and you switched it to a MOQ-based architecture instead, but you don't make any other changes, you're probably not going to really benefit from the unique features of QUIC,
not
right?
really. So you will be using a MOQ in a datagram mode. So it's just like a WebRTC. You send it and forget about it. So you don't care whether the packets or the data has arrived by on the receiver side or not. For certain applications, this might be still acceptable. So if there is some redundancy, or if any new information will already replace or augment the existing data, then maybe you don't really need full reliability, right? But if you are trying to watch something, on a Super Bowl night, or if you are trying to watch a movie on Netflix type of service, you really don't want to miss anything, right? So you don't want to skip any frames or audio dialogues and things like that. So, MOQ allows you to trade off latency and quality. So, if you give a bit more latency budget, MOQ is going to do better in terms of delivery performance. But if you really want to be on the cutting edge live point, like I really want everything in 50 milliseconds or so. It will still do its best, but it will not be perfect, right?
Yeah.
But at least we have this capability to configure our protocol based on our needs. WebRTC doesn't give us that capability, and Dash HLS cannot really get enough low enough for certain applications use cases. So hopefully with Media over QUIC, we will be able to do that.
And that latency tuning is per stream, I believe you said. Is that correct?
Yes.
So in for instance, if we were doing a drone related application, we could make sure that reliability is very strong for data and commands we're sending to the drone.
Yes.
Maybe data that we get back from it, but perhaps say like a live camera feed from the drone, maybe we could accept lower reliability of that.
Correct.
And so we can tune that independently of each of those streams, right?
But not only that, you are going to put the commands on the high priority stream, for example. I mean, if you want your drone to turn left or fly right, you want to be able to send that message right away as quickly as possible, right? I mean, it's so it's there's also not just the separation of the lanes or data and media, but also prioritization of those different lanes. That's important.
Yeah, interesting. Yeah, that's I think that's the overall message of this to me. And what's interesting is that there are definitely use cases where like WebRTC and MOQ can sort of do well together. Right? And certain use cases where you could use either one, especially around meeting tools that WebRTC was designed for in particular. So if you have a legacy WebRTC application for a meeting tool, you may not see as much reason to switch. But if you're building a new application or you're upgrading that drone application that you were maybe struggling with putting libWebRTC on a headset or something like that for wearables, you might have a better experience doing that with a MOQ-based application, right?
I'll give you one specific example where MOQ is going to make a lot of sense. Today, I mean, right now we are in a video conferencing application, right? And if somebody else just joined, they are not able to go back, rewind. I mean, on YouTube they can do that, but on this application or on Zoom you cannot do that, right? But Media over QUIC, we will be able to do that because we have this fetch AI, that will allow you to grab things from the past. So you can subscribe to the current live point, but maybe you missed a question or there was really some important information that you had to know before continuing with the rest of the conference, right? So you roll back, you listen to that part, and then you come back to the live edge. I mean, there is no way to do that in WebRTC unless you are really actually storing everything on the client side that will allow you to buffer. Even in that case, if you just joined, there is nothing to buffer because there's nothing in your buffer, right? So you need to be able to ask from the relay, hey, I missed the last 2 minutes. So let me grab those segments, frames, whatever, and then I will get whatever information I need and then come back to the live edge. So that's really like VOD, live, interactive, real time, everything is bundled up. And, there's a single protocol that will do everything for you.
Yeah. No, that's an interesting example, and it's a good example of something you would have to implement that capability at the application layer, but using MOQ underneath the application layer allows you to do that in a way that WebRTC would be much more complicated.
Or I want to do an insertion during my conference. I don't want to actually change my camera to my video source MP4 file, which is encoded, pre-encoded, and so on. I can just do this in my catalog, like a playlist, and then ad insertion will just come in, and then we will continue with the rest of the presentation. I mean, there are so many different use cases that will allow us to achieve with this. Yeah.
Absolutely. We're nearing the end of our time together, unfortunately, but a comment I just wanted to share, I'm not sure there's a question, but a comment from Upon there about how the data delivery report and data recovery option makes QUIC reliable because it's based on UDP. So
yeah. I mean, QUIC streams are reliable. QUIC datagrams are not reliable. Let's just put it this way. So there are two APIs for that. Right.
Yeah. So all in how you use it there for sure. Excellent. Well, As we are running out of time now, are there any other, anything else that we didn't get to from your presentation you want to make sure to cover, or other comments, things you wanted to share?
Well, I mean, I did a couple of mock presentations last week. I was when I was in London, and then it was more for streaming guys, broadcaster guys, and some of those slides are already on the website. But there are a couple of things that I want to share very quickly, because this work is done by my students, and I really would like to acknowledge. So today, as I said, there are a couple of different implementations out there, and then there are some implementations. Unfortunately, are not open source, so we don't know how they work. But if you go to our website, MOQ.streaming.university, you will see the initial. This is based on the first initial public implementation, which is Rust-based, developed by Luke Curley. Thanks to Luke, we grabbed his code and then added a bunch of features like client-side adaptive bitrate. So the client is able to change the, ask for different tracks based on the available bandwidth and so on. And we have a website. If you go to this URL, you will see that you can actually compare media over QUIC with low latency Dash. And my students, we are also contributing to Dash reference player implementation, Dash.js, quite a bit as well. And low latency Dash, while it's a great client, it's not really as good as with media over QUIC when it comes to latency. And you can see some numbers yourself here. This is all open source again, and you can play yourself as well. And another demo, at the same URL, we have the publisher and subscriber. This is just a test we did yesterday. So publishers in Istanbul, subscriber is also in Istanbul, and this is one of the relays that we use in AWS in Frankfurt. So the round trip time, network latency is just 50 milliseconds. And as you can see, the latency that we are seeing from publisher to subscriber, encoding, packaging, and decoding, playback, and then everything included is around 108 milliseconds. So less than 200 milliseconds. This is not even an optimized implementation. So this is really showing the capabilities of media over QUIC. And lastly, this is a senior design project that some undergrad students did just a few months ago. This is synchronized VOD playback. So there's a video that you want to watch. It's not a live video. It's a VOD, but you want to show it with your friends anywhere in the world. So you go to this link, you select a room, and then there's a leader, and then anybody else is going to be a follower. You join the room, and any change in the playback the leader does, it will be synchronized at the frame level with the subscribers. So this also shows how media over QUIC, something that was designed for real time, can also be used for VOD playback. So there are also some papers associated with this. And finally, my last slide will be about things that we are working on. Obviously, we can spend a lot of time on this slide, but I just want to cover them very quickly. Everybody thinks that WebRTC and Dash HLS work sufficiently well for their use cases. There's a huge installed base. We cannot really ignore that fact. So there will be some resistance, and there is no MOQ CDN today. But hopefully there will be some in the future, and then this will change, the equation. And we are working on adding ad insertion support, as also content protection support. This is especially for live sports. And congestion responses, prioritization schemes, how the relays are going to interact with the clients and so on. These are all research questions. So I'm really happy to announce that we are working on a new MOQ library. It will be open source, obviously. It will be on Mocktail. This is what we call it, Mocktail. Mocktail.dev. It will be available at the end of June. It is mostly there, but obviously we are fixing a lot of bugs and adding some new draft 11 features. So hopefully, in a month, you will be able to play with a new Rust-based media over QUIC library. So that's
Excellent.
all.
Very cool. Well, thank you, Ali. So yeah, for those watching, make sure to check out mocktail.dev. And then you also mentioned mock.streaming.university, another source here. And then, of course, your site too. I know you've got a lot of great resources up there and past presentations.
Yeah, and if anybody else is going to watch this podcast later, or maybe still have some follow-up questions, feel free to email me. So I'll be more than happy to answer anything I can.
Thank you, Ali. I appreciate it, and thank you very much. On behalf of our viewers as well as myself personally, to you and your students for all the work that you've invested in this, and everyone in the IETF working on the standard. I know that's a long process, but we will all certainly benefit from it. So thank you. Appreciate it.
Sure, my pleasure. And thanks
all
for
right. It's my pleasure. Thanks so much for joining me today, Ali. Take care.
Bye-bye.
Okay, and so thanks. Yeah, great conversation. Thanks to all of you who watched today's episode and for the excellent questions we had, and to Ali for sharing his expertise. In just a moment, I'll have Sahi joining me for our industry analysis segment, where we'll talk about the CPaaS adoption of AI. But first, let me remind you that this video will be available on the WebRTC.Ventures YouTube channel, as well as on our blog at WebRTC.Ventures. Our next episode of WebRTC Live will be Wednesday, June 18th at 12:30 Eastern US, with our guests from WebRTC.Ventures, Hector Zelaya and Daniel Phillips, who are going to talk about UX and architectural challenges when integrating voice AI into your WebRTC application. They have a lot of really interesting insights to share. So yeah, I encourage you to definitely check that out. To find out more about our upcoming episodes, follow us on social media at WebRTC.Ventures, on Twitch, LinkedIn, YouTube. Join our email list at WebRTC.Ventures. Thanks everyone for joining us today. Let's make it live. Thanks for joining me today, Sahi. We're going to talk about AI in the WebRTC marketplace a bit today. You've told me that you feel programmable video is leading the way in AI technology adoption and doing a better job of it than CPaaSs. Tell me a little bit more about that.
So when I did my generative AI and WebRTC workshop, I went to see what different vendors are doing. It's important to do your research. And when you look at that, you start looking at what the leading vendors in voice and SMS do. And then you see what the video-centric vendors are doing. It's not the same things. Mm-hmm. So when you go to the voice vendors, there are two things that you see. Either they add something that is, it's already prepackaged in there. You can call a number. There is a chatbot that was already placed there. They decided what speech-to-text and text-to-speech engines are going to be used for you, what is the LLM that is going to be used. You can provide RAG or whatever, or knowledge base, links, documents, uploads, whatever. That's it. Or you can go and do the Flow Studio thing where you put a box after a box, and what you do there is you add a box with the word LLM on it, and whatever. You get text in, text out, and that's the end of it. The most weird or interesting one that I found was actually Telnix, where what they seem to be wanting to do is they say something like we're AWS, which again made little sense to me, but fine. They sell their own GPUs to run whatever models you want, or out of the model, 20 different models that exist, you can run on their machines instead of running that in a different cloud. So that gives you like maybe lower latency, different cost, scaling, whatever. But it doesn't feel like something that a CPaaS vendor should be doing. They're likely doing that simply because they're saying the same about their carrier network, that they own the network and not use less third parties than others.
Right.
But at the end of the day, when you look at it, the mindset of the CPaaS vendors or the ones doing voice and SMS is for AI is the same as what they do for voice and SMS, for phone numbers, which means, let's think about CPaaS. CPaaS does something, let's dumb it down. What they do is provide aggregation of telcos.
Mhm.
I look at all the telcos in the world, or enough of them, 1 or 2 per country, because I need numbers in all countries. I go do a contract with them. I integrate with their APIs or interfaces, and I abstract that from my customer, giving them my own set of APIs. Now, the end user or the end developer doesn't really care if the call goes through Verizon or AT&T or T-Mobile or whoever. He just wants the call to go through and the quality to be good. Oh, and the price to be low. Or he wants the deliverability of the message to be high and the price to be low, things like that. So at the end of the day, there is no competition about the type of service, but rather about the quality of a service that is uniform across carriers the world over.
Mhm.
Now, if you go with that mindset of saying, well, what is our core business? We provide aggregation of carriers, and our barrier of entry is our contracts with the carriers and the fact that we offer, we simplify the interfaces for you. That's nice. Now you take that and try to copy it to the world of AI, and you say the same things. You've got OpenAI and Gemini and Claude and whoever. It's all LLMs. So our customer doesn't really care as long as we give him prompts. He will be happy. And you look at the text-to-speech and speech-to-text and say, well, what's the main, what difference does it make if you use Amazon Lex or something else? Or you go and say, well, we'll take 11 labs on the text-to-speech, Deepgram on the speech-to-text, because they are the market leaders. We're done. That's it. It doesn't work like that. That's the only problem that you have. And when you look at what the programmable video vendors are doing, the video API vendors, especially today, Agora, LiveKit, and Daily, which are in a way leading that front, is actually built a full-fledged AI frameworks. All three are using open source for that. So they built that in open source. And now they're starting to provide cloud hosting of these as well, where the main premise there says two things. First of all, I have no clue what it is that you want to build. I don't know, because when you want to build a video use case, I don't have a clue what you want to build. It's one-on-one, one-to-many, a group call, small group, large group. I just don't know. What's the resolution of it? It's like there's too much variance there, same as there is with AI. Unlike voice and SMS, which is just voice and SMS. So they came towards that and said, well, let's build the whole pipeline, work on the latencies, do the things that we know how to do for video on AI. And because there are too many partners, we're not going to be too opinionated on which the partners are. We're just going to bake into the framework the ability to add additional partners in the future. And you see things like Pipecat supporting 50 or 60 integrations with different AI vendors today. And, LiveKit, probably the same number, or 50 or 40, something like that. And 10 doing, which is Agora, doing large numbers as well. So they're like, if you want Russian or Chinese or Indian or a different accent, that's fine. You just either use what's there already or add your own, because it's open source, so you can just add that kind of an interface or integration. It ends up being more in line, I think, with what the industry needs, at least at this point in time, not 2 or 3 years into the future when, consolidation, less vendors, less whatever, but today it makes a lot more sense. That's what I wanted to say.
No, I agree. And I think it's an important observation because, right now there are a lot of different models. There might be consolidation in the future, as you said, around a few central ones. I think even if we get to that point of kind of like we've seen in WebRTC and communication space, even where you have consolidation around a few particular vendors, there's always going to be others who serve a particular niche, right? There's always going to be, just like in the WebRTC space, somebody who does a better job with large scale broadcasting, right? Versus contact centers or whatever. And in the LLM space, you're going to see the same thing. Somebody who deals with particular accents or particular industry verticals better. And so I think it's really smart for these companies to have that infrastructure and to have that infrastructure be flexible, because for us as developers using that, it gives us an incentive to stay with them as the framework, even as we're changing models and over time as different models come out and offer different capabilities. So I think it's really important, you know, and I think, you know, and just to kind of like quickly define, like a CPaaS is that larger umbrella of people who also provide voice and SMS, programmable video may be part of that. But then what we're talking about, the people who seem to be doing a better job of offering AI capabilities and more flexibly are those who tend to be more focused on WebRTC based video and voice, as opposed to those who have kind of this carryover from a more legacy telco industry, right? And so, you know, do you think that sort of telco inspiration, that telco history that the larger CPaaS providers have, that is that what's kind of holding them back from thinking in this different way?
Yes, I think so, because, you know, I've worked with companies and I worked inside companies in the past, and you see that companies usually will have their own echo chamber. We know how things work. We do it on a day-to-day basis. We see our customers. This is what our customers ask from us. So this is what everybody wants. It's like, that's obvious. I had a discussion recently, you know, a back and forth over email with someone because of my API report, and he wasn't happy with some of the scoring and whatnot. And I tried to explain to him that the fact that his customers are so happy about the product doesn't mean that he sees the market or the whole market, because there are others that don't even come and talk to him because whatever he has doesn't have the flexibility that they need.
Yeah.
And I think that in many ways, the voice people see only these use cases, and within these use cases, they're likely focused on contact centers, and in there on agentic AI in the form of let's replace the contact center agent with a bot. That's one. And the other one would be let's do transcription, and then from there create summaries and dashboards and whatnot. And when this is the mindset that you have, then when someone comes in and says, well, I need to be able to do a group call that gets simultaneous translation of all languages, we can't. Or I want to be able to also provide video or look at video and do vision type of a use case within your platform. And then the answer is you can't, but if you use that directly, and then so it becomes kind of a half-baked solution for someone that needs something that is not rather focused on what CPaaS vendors are now looking at, and they're not looking at the whole market anymore.
Yeah. And perhaps that will, you know, be fine for them given their customer base and kind of, you know, the market niche that they want to serve. But yeah, you know, you've mentioned a few good examples of leaders in the space on the programmable video and AI side, Agora with 10, Daily with Pipecat, LiveKit with their real-time agents. And, you know, even though they're more, maybe come from more of a CPaaS background, you know, I think it's interesting also, like SignalWire's talking about AI as an agent infrastructure too. So that may be a case where there's a little bit of a blend between those different perspectives and looking at it.
Yes,
It'll be interesting to see.
That's true. I looked at that, but what they did was added that into their scripting, which is okay-ish. But then again, how do you pick and choose the algorithms that you want, and can you use your own algorithm or a third-party algorithm, or how do you? The answer is no, you can't. And I think that's where things become murky or challenging again today. And not for all companies, but for those that are doing things that are a bit more complicated, which means video.
Yeah. Video and more unique LLM integrations, which is, you know, I think the areas that are of particular interest to people like you and I.
Look at what Daily is talking about all the time. So, and LiveKit, turn detection and stuff. And how do you do that? We do that with VAD, voice activity detection, or do it with an SLM, a small language model instead? And how do you build that? And what languages that you need to support? And then there's a question of how do you go and reduce latency throughout the pipeline? And one of the things that Daily came out with a few months back was, let's run everything on the same Docker container. So speech to text, text to speech, LLM, single Docker, everything there. You can't do it with a cloud vendor anymore because it's like you need to host it somewhere, and that needs to be close to your actual vendor.
Yeah.
And if you think about it today, all of these algorithms are getting consumed from the cloud, but you don't really know where. Does OpenAI run their servers on AWS, on Azure, on something else? So if my CPaaS vendor runs on AWS and OpenAI runs on Azure, and I'm going to use text-to-speech that might be on, I don't know, Google Cloud, just because that the vendor that I chose works on, I'm going to take my audio and move it, from one cloud to another, ping-ponging just to get the things that I needed. Just moving that back and forth is going to not only be a pricing issue, but mostly a latency issue that I'm introducing into a problem where what we're trying to achieve is lower latency. And I'm sure that the CPaaS vendors are working on solutions, but again, these are going to be very opinionated. That's my worry, or just an insight that I had looking at the market from the sidelines.
Yeah, no, inevitably with consolidation always comes strong opinions on how to implement things. So I think there's, that's where there's always going to be space too for edge cases and more unique implementations. And that's why I think it's smart for a lot of these providers to offer something that's more of a framework rather than too highly opinionated. So, well, Sahi, as always, thanks for your insights and sharing those with us today. Anything else you want to add today?
No, enjoy.
All right. Well, good luck to everyone working out there with real-time agents. We'll be certainly interested to hear what you're building with them too, and feel free to reach out to us at WebRTC.Ventures and for WebRTC Live about that. So as always, thanks for sharing your insights with us today, Sahi. And for those who want to learn more about Sahi's work, check him out at bloggeek.me. To learn more about future episodes of WebRTC Live, check us out at WebRTC.Ventures. Thanks, Sahi.
Thank you.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.